Okay, example 8. A manufacturer finds that the costs incurred in the manufacture and sale of a particular type of calculator are $180,000 plus $27 per calculator. Determine the profit function given that X calculators are manufactured and sold at $59 each. So, we saw a problem similar to this in the last chapter. They kind of did all the setup for you this time. You got to do a little bit more of the setup yourself. As far as the last time they told you to find the cost function, the revenue function to get the profit function. But in general, profit function P of X is equal to the revenue function minus the cost function. So anytime you're asked to find a profit function, that's simply how you do it. You find how much money you're going to take in with the sale and subtract away the cost of manufacturing it, and whatever's left over is profit. All right, so looking at revenue, starting with revenue here, all I care about with revenue is how many things do I sell and how much do I sell them for. Okay, we always assume we're going to sell everything we make because we're making the best product possible. Anyway, we're going to manufacture X calculators, which implies to me that I'm going to sell X calculators. If I make 100, I'll sell 100. If I make 500, I'll sell 500. So we live in a perfect world where everything we make is sold and all is great. All right, we're selling them $59 each. All right, so the revenue function is simply how much do I sell it for times how many do I sell. That's typically how a revenue function is made. They're pretty simple. Cost function is usually a mixture of a couple things. How much does it cost in materials plus labor force? That's a per unit cost, along with usually a set fixed cost for whatever building you're going to use or maybe the equipment you're going to use. So if I have to buy some machines to help build the calculator, the machine costs a certain amount of money. All right? If I have to hire a person to work the machine, I have to pay that person per hour, per unit, per something. All right? The materials, the plastic and the silicon and all the calculator chips or the computer chips and stuff needed are going to cost me per unit. So you can see here that the fixed cost is $180,000 plus $27 for every calculator I make. All right, so the cost function in this case is going to come down to those things. It's going to cost me $180,000 plus $27 for every calculator I make, of which I'm making, again, X calculators. So I can get the cost function, revenue function, both in terms of this variable X, X representing how many calculators I'm going to make. Okay, which creates a profit model. If I take my revenue function, 59X, subtract the cost function, notice the cost function almost always is more than one term. Make sure you put the cost function in parentheses when you subtract to ensure that subtraction distributes through. So minus 180,000 and minus 27X is going to get me an ending profit function of 59X minus 27X, which is 32X. Again, 59X minus 27X got me 32X. And then minus 180,000. All right. So you're going to be asked to do that in some problems. Some problems will give you a revenue function, cost function, ask you to find profit. Other times they'll make you create the revenue and the cost function. But anytime you're looking for profit, you're looking for those two things. Revenue minus cost gets you profit every time. Next, determine the break-even point. So you're running a business, you've created your profit model, right? And now you want to determine how many calculators we have to actually make before we start making money. The break-even point. If I make 0 calculators, I lost $180,000. That's my profit function. Make 1, I got $179,968 in the hole. So I'm less money in the hole, but I'm still in the hole. Break even is when profit equals 0. So if you see break even point, that means P of X equals 0. At that point, I don't owe any money, I haven't made any money, I broke even. Not a great way to be in a business, but it's better than owing $180,000. That's the point we get to. So in this case, if I set my profit function 32X minus 180,000.
That's why they taught us that P of X equals 0. Right?
Exactly, equals 0. Yeah, that's why we got to that x-intercept thing, right? So if the profit equals 0, we take our profit function equal to 0. That means 32X is equal to 180,000. Divide both sides by 32. I'm getting 5, no.
5,700. 5,625.
5,625. Thought it was gonna be a nice little division, but that had to be 160 divided evenly by 32. So 5,625 calculators. All right, so what that tells me is if I want to go into this business of making calculators, I've done my research, and I found that people are willing to spend $59 for this fancy calculator I'm making, and it's only going to cost me $27 to make it, but this startup cost of $180,000 is there. I know that if I make 5,625 calculators, I'm going to be breaking even. If I find out, though, that about 25,000 people want this calculator, then I can determine beforehand what my profit is going to be based on that. So if you put 25,000 in there for X, you figure out how much profit you're going to make. So a lot of times businesses do that. They'll do surveys of people some way or another. How much are you willing to spend for this thing, that, or the other? A lot of times when a new restaurant comes to town, they'll do that kind of stuff to figure out how much interest is in this new restaurant to see if they're going to be financially capable of doing it. So that's the type of business decisions you have to make a lot of times. This is very, very, very basic. Real life profit functions a little bit more complicated than that, but this is just a basic introduction into this idea.